get it out? You finish it? Yesterday. I did that. It was actually. Yeah. You said it was super hard. I didn't understand. I was rushing. You said it was so hard, and then it took not. Okay. I still have enough. Not long. I finished it. It was just. I was looking for. You just literally had to look at the kids. Yeah, but I didn't even have scrap paper. It was in my head. So the part that is so easy was the multiple. That's one. So I'm like, I put it said the answer, and it says or, so I'm like, I have this. I didn't know you had to put all. That was my so hard. I was like, I usually have the answer, and then so but I didn't understand. So I had to have coordinate. Suppose there's like 8 answers. Yeah. No, the max is 4. Yeah, I think we just went up to 2 I would think that the person with the answer do it, but sometimes it's like I know how to do like all the full signs, but then name it names, but then sign I can figure out what. So here's the wow. Yeah. I think my search. I really finished that. Yeah, so that right state thing, is this, I just filled out that application thing. Is it, so you filled out the application? And I got an email from you. Okay, so, but then it says those documents. Did you, as long as you follow the links, you should be fine. Did you follow those links that I had posted on the Google Classroom? Yeah. Yeah. Then you're good. Okay. You should be good. It is, let me do this. Yeah. Advisory. Yes, this is right. Yes. That's good, that's good. Clip.
send this. Okay, good, there we go. All right. How many days do we have left? How many actual days before the first exam happens? School days in the room. You guys know? 11, isn't it? 4 next week. Then the last week you only have 3 because that Friday is the first exam. So it's 11 days, okay? So in those 11 days, listen up. In those 11 days, we're going to be doing solving trigonometric equations. Okay, that's this week. We're doing solving trigonometric equations this week. So we're going to spend today, tomorrow, you'll practice them on Wednesday. Thursday, we'll do some in review. And then Friday, we're going to finish it up with some kind of an assessment. Next week, we're then going to look at what are known as polar functions or polar equations. Okay, we will do that for probably Monday and Tuesday. We might do Thursday, Friday. I haven't decided yet or not what we're going to do. And then the last thing we have to do in here is we have to go back and do what are known as rational functions. So we'll step out of trig. We're going to go back to what are known as rational functions, and we're going to talk about asymptotes, end behavior, and limits, because that is something I want to do right at the end before you guys head off to the summer, because next year, that's the first thing you're going to start calculus with. So we're going to end the year with rational functions and limits, because next year, that's where you're going to start. I know that for calculus. Okay? So again, that's what's going on in here. Okay? That's what's going on. So let me go ahead. I know a lot of people, I was looking at last period, what was going on with Delta Math, and we were all over the place with some people having done it, some have not done it, some did it and did well, some did it and did not do well. So the whole idea I gave that to you is to see where are we on anything from basic to more complex. They're not like the most complex, but more complex. Those were solving trigonometric equations. That's what we're doing this week. Okay, so we're going to be doing that today. We're going to start with some basics today. Hopefully then once you're done with that, things that you saw yesterday or on the weekend or whenever you did it, you'll go, oh, that makes a little more sense now. Okay. All right. Let's see what else. Friday, I got to see real fast. Have your quizzes here. And let's see, who was absent that day? Anybody? True was absent, and Caitlin, I know you were at AP test, so I have to figure out when you can come take it. Those are all online, so those two. Okay, so I'll talk to you individually, Caitlin. For those of you who took it then, did you feel like I gave you at least 3 that you were good at for sure? Yeah, I tried to put some on there that were pretty not real complex. So I will be grading those. I'll get those back. You'll know how you did. I have not looked at them. They were just sitting here over the weekend. Okay, so there you go. And I do appreciate, I mean, he said you guys are all great. So that's huge. I appreciate you guys being great. And I expect nonetheless than being great. So, all right. So let's get going here. We don't have time to waste. We got to get going here today. Feel the crunch. Feel the crunch. So we're still dealing with trig. And if I put something up here, I would hope what I put up here in a second is not something you say, I have no clue. Because if you have no clue, you're going to really struggle on the solving. Okay? So, all right. Here we go. Circle, unit circle. Everybody knows this, of course, is 0. I want it in radians. We're going to go around this. You guys should know this. You should know this. Okay? So, here we go. Where am I at? Pi over, pi over, pi over, pi over, 2 pi over, 3 pi over, 5 pi over, and if you don't know those, that's a problem. Okay? Then we jump down here. 7 pi over, 5 pi over, 4. What's this one? Quick. 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over, 11 pi over. So you'll notice that anything that's over 3 is by the vertical axis. Anything over 6 is by the horizontal axis. And then all the pi over 4s, the pi over 4 family are always right smack dab in the middle. So you always know the pi over 6 family, that's what I call these. The pi over 6 families are always right next to the x-axis. The pi over 3 family is always right next to the vertical axis, and the pi over 4s are always smack dab in the middle. We have to know those. We should also know the ordered pairs on these still. Okay? Like we should all know this ordered pair right here is at what? 1, 0. This is at radical 3 over 2 and 1/2. This is at radical 2 over 2, radical 2 over 2. This is at 1/2 radical 3 over 2, right? And if you know those, you automatically know all the other quadrants. Why? It's just changing the signs, depending upon what quadrant you're in. Okay? That's it. Let's go ahead and we'll finish writing these down. Of course, this is at what? 0, 1. This is at negative 1/2 radical 3 over 2. Negative radical 2 over 2. Radical 2 over 2. Negative radical 3 over 2. 1/2. Negative 1, 0. Okay, those we should know. So here we go. How many angles have a y value of 1/2? How many angles have, on this picture, how many angles have a y value of 1/2? 2. Where are they, Brady? Yeah, first and second quadrant, right? And those would be what? Pi over 6 and 5 pi over 6. How many angles in the unit circle have an x value of radical 2 over 2? 2. What are they? Pi over 4 and 7 pi over 4. I mean, that's just looking at it, you should be able to tell me this. How many of them have an x value of negative 1? 1. Where's it at? Pi. Okay. How many of them have an x value of negative 1/2? 2. Where are they at? 2 pi over 3 and 4 pi over 3. Okay, now look. When I'm giving you how many have an x value of this or how many have a y value of this, I could simply say instead, how many angles up here are there with a sine of 1/2? Because if I said how many have a sine of 1/2, we know that the what value, the what coordinate is the sine, the y. So if I say how many angles up here have a y value of 1/2, I could just as easily say how many angles up here have a sine of 1/2, and I'm asking you the exact same question. That's it. Knowing the unit circle, though, allows you to give me those answers. So if I said, how many angles up here, okay, have a, let's go with this. How many angles up here have a cosine of negative radical 2 over 2? There are 2. What angles have a cosine of negative radical 2 over 2? 3 pi over 4 and 5 pi over 4. You just solve, that's solving a trig equation. That's it. That's all solving a trig equation is. Telling me what angle has the following sine or cosine. And it could be tangent. But sine and cosine is where we start. Why? Because those are just the x and the y coordinates. That's it. So if I have these up here, and I say, okay, I want to solve for all values of x such that x is between, I'm going to go ahead and go like this, 0 to 2 pi. I just want to know in one rotation. Okay? That's all I want to know. And I said, give me all the values of x where the sine of x is 0. All you're thinking in your head is, where on the unit circle is y equal to what? 0. Where does that happen at? Where's y equals 0? 0. Look back here, guys. This is why you have to know this. 0 and pi. So you can tell me here that x equals 0 and pi. I'm going to change this up here real fast. I don't want to include 2 pi. If you remember about intervals, this is, we're going to start from 0 and we're going to go up to this, but not include 2 pi. Okay? That's a repeat. 2 pi is a repeat of 0. 2 solutions. Done. Okay, I come over here. I said, okay, I want to solve cosine of x equals -1. So now I'm asking you, where is the what? X coordinate -1. So you're looking on that unit circle. You're thinking it. You can't write it down every time, guys. You have to know it in your head. You have to visualize it in your head. Where am I at if the x value is -1? Right there, pi. I have to know that here, x equals pi. That's it. That has one solution. 1. Now, this is just knowing your what? Familiar angles. That's all this is right now. Still knowing the unit circle, knowing the coordinates, and the relationship of those coordinates with sine and cosine. All right. Now I get crazy on you. Because what has happened? Now all of a sudden I didn't give you sine and cosine, I gave you cosecant and secant. But we have been spending a lot of time. Because I know that I can change this. I know that if the secant of x is -2 radical 3 over 3, I know that the reciprocal of this, which is what? 1 over cosine. But guys, so this is 1 over cosine of x equals this. So what do I do to both sides to keep it equal? I do what? Flip them. Invert them both. So what do I know that the cosine of x equals then? 3 over -2 radical 3. And you say, Mr. Schneider, I don't recognize that. Now look, here's the deal. I've told you all year long I wasn't going to make you rationalize denominators, but I told you you needed to know how to do it. Here's an example where I need to know how to do it. I need to make this look familiar to me. How do I rationalize the denominator? Yep, multiply this by radical 3 over radical 3. That's what I do. That's it. In doing that, I get 3 radical 3 over -2 times, what's this going to give me right here? The whole number of 3, correct? What are these 3's going to do? So what do I have here? I have that the cosine of x equals radical 3 over -2. That's a familiar angle. So I'm asking you, on the unit circle, where is the what coordinate? Which coordinate now? X. Where's the x coordinate? Negative radical 3 over 2. So I'm visualizing in my head. Where does that happen at? And I also, guys, I also know what? There's so many things that I've done in here with you. All students text constantly. What are these? These are where they're what? Positive. If the cosine's negative, I know what quadrants it has to be in. Which ones? 2 and 3. I know my angles in 2 and 3. So, okay, what are my angles going to be here? What angles have an x value of negative radical 3 over 2? Yep. There they are. I've solved it. In my head, no calculator needed. Familiar angles. We're using the familiar angles still. All right, here we go. On the right-hand side, if the cosecant of x equals radical 2, somebody tell me what the sine of x must equal. Think. Don't rationalize anything yet. 1 over radical 2. Flip it, right? Boom. That's what it's going to be. It's the reciprocal, guys. Okay. Rationalize it. That means that the sine of x is equal to what? Well, multiply by radical 2 over radical 2, which is radical 2 over 2. Oh, okay, here we go. Where does that happen? Well, sine is positive in 1 and 2, so I'm here and here. So what? Pi over 4n? Pi over 4 and 3 pi over 4. That's where it happens. Now, for those of you who are struggling with this right now, mentally, how is this happening? I don't understand what's going on. Here we go. Okay. Somebody tell me where a sine curve starts. Basic sine curve. Where's that on this? 0. Starts here. Then where does it go at pi over 2? Maximum. Then what? Midline. Then what? Minimum. Then midline. Okay, so this was the curve. Boom. If I said to you, where is the sine of x equal 1/2? 1/2 is right here. How many solutions? That's why I'm getting 2 solutions graphically. I'm asking you for those 2 locations. Oh, where's this at? Pi over 4 and 3 pi over 4. I can see it there graphically. Now, guys, I can tell you, when we take the assessment Friday, you're not going to do these graphically. You're doing them algebraically. You're not going to have Desmos out at all for this. You have to be able to do these without using Desmos. You have to know them. For some of you, you're going to have to go back and look at the unit circle again. Okay, so this is the idea. Now, guys, really and truly, we know that the sine of x does not stop here. It goes on forever and ever and ever. So really and truly, I know that this would go back up and it would come back down again. And if I drew this blue line out further, it would do what? It would hit 2 more times. Can anybody tell me how far apart this is from that one? Why? You're right. That distance is 2 pi. Why? It's the period of the function. It repeats every 2 pi radians. These would be 2 pi radians apart. This one and this one would be how far apart? 2 pi radians. Okay? That's what happened. It was periodic. It happens over and over and over. How far are they spaced out? 2 pi radians. Why? Because that's the period of the sine curve. That's the period of the cosine curve. All right. Okay. We haven't even talked about these two yet. Here we go. Tangent x equals 1, cotangent x equals -1. I want to know where these are. Okay? Now let's think about this, guys. If the tangent of x equals 1, that means the numerator and denominator have to be the same. I know that tangent is sine over cosine. So I'm asking you, really and truly, on the unit circle, I'm asking you what? Where are y and x exactly the same? That's what this is asking you. Where are y and x, those coordinates, exactly the same on the unit circle? Well, where are they the same? Well, I know that tangent is positive in quadrant 1 and quadrant 3. I'm supposed to know that at least. So in quadrant 1, where are they the same? Where x is equal to pi over 4. In quadrant 3, where are they the same? At 5 pi over 4. Boom, done. Yes. Not always, no. Not always. These are because it just happened to be that I wanted the tangent of 1. We'll look at something like that, okay, later on. We're starting basic. Those are the easiest ones. Okay, cotangent of x equals -1. What is this saying now? That my x and y's are not exactly the same, but one is and one is. So their absolute values are the same, in other words. That's what we're saying here. Okay, so where do we have that happen at? What quadrants? 2 and 4, because that's where tangent's negative and so is cotangent. Okay, so here, x equals what? 3 pi over 4 and we're solving trig equations. These are not even any steps. There's no steps involved with this. This is just solving it. Okay? Again, I have to know the unit circle. I must know those ordered pairs without fail. I must know that each quadrant tells me what's positive and what's negative as far as sine, cosine, tangent, cosecant, secant, cotangent. I have to know that sine is the y. I have to know that cosine is the x. I have to know that tangent is what? Y over x. I have to know that then it's the opposite, the reciprocal of all of those. Anytime I get a cosecant, I rewrite it as a sine. If I get a secant, I rewrite it as a cosine. That's what I have to realize. All right. Here we go. This one. Somebody tell me, okay, I don't want to know the angle yet. Tell me which coordinate am I interested in this problem on the unit circle. If I'm dealing with the cosine, which coordinate is it? X. So I'm asking you on the unit circle, where is the x coordinate? Negative radical 3 over 2. So what quadrants am I in? Think about it. Where am I at? Negative. I'm here and I'm here. These are the two quadrants I have to be in. That's where x is negative. And the x I'm talking about is not the same as that x. That's an angle. The x I'm talking about, the other one is like ordered pairs. So what value of x, what is the angle x in this problem? What's this going to be? 5 pi over 6. Thank you very much, Dylan. What's the other one? 7 pi over 6. Two solutions between 0 and 2 pi. Two solutions. Will I always have two solutions? No. If I'm on an axis, I may not have two solutions. Because let's just do an example. What if I said, I want to know, like, when is the sine of x equal to, oh, I don't know, how about 0? Not 0. How about I make it sine of x equals 1? When does this happen? How many times is the y value 1? Once. Where at? Pi over 2. That's right here. So when you have them on the axes, you may not have two solutions. You may only have one. But if it's in one of the quadrants, actually, you're going to have two. All right, boom, this one, here we go. Where am I? So the sine of x equals -1/2 when the angle x is either what? What quadrants, guys? 3 and 4. Has to be right below the x-axis. It's only down -1/2, guys. What is that? Right. So this is like, I think, how the Delta math started. Just basics like this. That was it. They were just asking you to use the unit circle to decide where am I at if the sine or the cosine or above is this. That's it. That's solving a basic trigonometric equation. And from there, we can only get more complex. But you can't do this if you really don't know the unit circle. And if you don't know the unit circle, you better start studying it again. All I can say to you. Now, we are going to start looking at problems that are more complex, okay? So, in a sec, I guess I'll do these first. I forgot I had this many problems already written down for you. Here we go. I don't like secants and cosecants, so I'm going to rewrite them as what? Cosines and sines, right? Okay, so if secant of x equals 2, then what? The cosine of x equals 1/2. Flip it, flip it. All right. Where does this happen? When x is equal to what and what? This is going to have two solutions, guys. Where does this happen at? Pi over 3 is one of them, and this is going to be in quadrants 1 and 4.
5 pi.
That one. 5 pi over 3. And remember, guys, if one of them is over 3, the other one is 2. Because they're from a family. They're from a family. Remember, these have the same x value. That's why they have the same cosine values. Okay? All right. Cosecant x equals -2. Don't like it. So I'm going to write this as the sine of x equals negative what? 1 over radical 2. I don't like that either. Let's rationalize it. What's this going to become? Radical 2 over, boom. I like that. Where is the sign in the unit circle? Negative radical 2 over 2. Three pi over 4? I'm going to be in quadrants 3 and 4 here, guys. 5 pi over 4 and, yep. Okay, so this is, guys, this is where it starts. This is where it starts. Being able to do these basic, I give you this, you may have to rationalize it, but then you have to know where it is on the unit circle. Okay. Okay, so anyone ask any questions before I go further? Anyone ask a question? I think a lot of you are probably going to go back and look at the unit circle hopefully at some point. Yeah, Ryan. I can turn it now. Once I give you a test, if you wrote it down, that's out of my hands. Like if I gave you a quiz or a test and you decided to quickly write it down at the top, that's your choice. You have to do it from memory though, right? I mean, that's completely different than me saying, you know, I'm not gonna say take out your unit circle and use it on the test. You have to know it. You have to memorize it at least to write it down. And if you can memorize it, you can probably think it through then. You probably could. You can write it down that fast. Okay. All right. Anybody else? So before I do any harder trig equations with you, excuse me, somebody tell me when you first started solving equations, what were the, now look, we just got on with verifying. Now we're solving. They're two different things. What are the rules for solving equations? Huh? Isolate the variable. Yes. Yep. Isolate the variable. That's what your goal is. How do you go about doing that? Yeah. So we usually unpack it the opposite. In other words, we undo addition, subtraction. We undo multiplication, division, next. And we undo any exponents. And then we would undo any parentheses at the end if they had them. That's kind of the idea. Now, that's not set in stone, but that's the basic idea of how you do it. You unpack it. What else? Yeah. Yeah. Probably the most important thing that you guys were taught. They said it to you a bazillion times, and it's different than verifying. This is where I was in verifying. I said, don't do this. Whatever you do to one side, you must do to the other. Right? That's different than when verifying. And verifying it was, whoa, 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 whoa. We're not moving things left to right. We're not going ahead and trying to solve it. We were just renaming it and making it look different. Now we're actually allowed to move things around. So the rule is, whatever you do, the same thing. Do same thing to both sides. Now, when I say that, okay, that does not mean that on the left, if I decide to factor it, that I have to factor the right. It's saying if I change its value by doing something new to it, I have to do it to the other side. So if I add 5 to the left, I have to add 5 to the right. If I add 6, if I divide both sides left by 2, I have to divide the right by 2. That's what that means. Okay? But it doesn't mean if I all of a sudden here said, oh, well, I'm going to rewrite this as the following. 3x minus 2 over 2 equals 8. Since I did this on the left, do I have to do that on the right? No, all I did was what? Change its appearance. So it's possible you'll do something to one side that you don't do to the other, but you're not really changing its value, you're just changing its appearance. Okay? That's what I'm saying. Those are the things you still have to know. You still have to know that. All right? So having said that, let's jump into the realm of solving now equations that are trigonometric and are not just, boom, giving the answers. You have to isolate the variable. But this time, you won't be isolating the variable. You'll be isolating the trig function. because the variable is attached to a trig function. Okay? Here we go. I wrote some problems down for us. Boom, here we go. 2 times the sine of x minus 1 equals 0. Now, how do I know that that minus 1 is not attached to the x? It would be in parentheses. Okay? So this, and I'm going to erase this and this, are not the same equations. You understand that? They're not the same equation. They're completely different. So you have to recognize that this and this are not the same. Okay, so my goal here is to isolate sine of x. So how do I get rid of a minus 2 and a minus 1 and a times 2? What should I undo first? Yeah, get rid of that minus 1. So I'm going to add 1 to both sides. Whoop. 2 times the sine of x equals 1. And now I'm going to divide both sides by 2. And now I get that the sine of x equals 1/2. That's exactly what we did in the previous 5 slides. We have to get to this, though, by now manipulating the equation. And then I have to use my knowledge of the unit circle in order to solve this. And it's not going to have one solution. It's going to have 2 if I'm between 0 and 2 pi. So we're solving this from 0 to 2 pi. All right, here we go. Where does this happen at? First and second quadrant. I'm going to write that down here. Boom, boom. Okay, good. So what are the angles? What does x equal? Pi over 6 and there. Now you just solved a 2-step trigonometric equation. That's it. You just solved a 2-step trigonometric equation. Questions on that one? Kind of like solving a linear equation in a way, wasn't it? The original part was just like solving the linear equations you did in Algebra 1. The only difference now is when you get down to the very end, you have to know your trig. You're using trig at the very end. All right, let's do another one. Here we go. Okay, so this would be like those equations where you have variables on both sides. Right? That's what this is. So this would be like a problem if I gave you this. If I gave you y plus 1 equals negative y, what would be your first step on this one? You'd get the variables on one side. So here you might do what? Add y to both sides, right? You might add y to both sides. So you get them on one, you have to get the variable on one side. I have to get the trig functions on one side as well. I have to. Same idea. So I'm going to start by adding a cosine of x to both sides. And now these are like terms. What is a cosine x plus a cosine x? 2 cosine x. Okay, now this looks like the previous problem almost. Now I do what? Subtract 1 from both sides. And now I divide by 2. And I get the cosine of x equals negative 1/2. And then I have to say to myself, okay, the cosine is negative in quadrants 2 and 3. I know that in my head. So I know that this is asking me on the unit circle, where's the x coordinate negative 1/2? That happens at x equals 2 pi over 3 and all right. Again, same idea. We have to isolate the trig function by itself. Then we have to use the familiar angles to solve. All right. All right. So in a second, we're going to take a break in a second here. When we come back, we're going to keep going. We're not doing every type today. Today we're looking at some certain types. So this one right here, these would be kind of like this, your 2-step equations. For the most part, these are kind of like 2 steps. They're not real crazy, okay? When you come back, we'll keep going. You guys are like in shell shock or something, it looks like. Okay.
I did. She's still mad at me. Sorry.
You know what I'm gonna do? Yes.
They're in shell shock. This is how what just happened here today, I think. They can't even think right now. No, I don't think that's it.
Oh, you're doing process. You're doing science.
Studying.
You're practicing. What, nice person?
Reading assignment, notes, yellow paper, an ed puzzle, and was for our quiz. She's so nice. I did none of it. Literally. I did the ed puzzle and I filled out the things and I did nothing. I probably could have We might not have also correct.
She could come back.
Not
Should come back.
She could.
Oh, I think she is correct.
Brilliant.
Who? Suzanne? She called you? That's great.
One.
Oh. No, she. I can. Not. Very nice. Right. No, not you. That's how you say it. That's a name. It's very common. He says Danya. Danya. You read that? It says Danya. He's just ready for Spanish. Danya. Her name's Donna. D-O-N-O-A. Donna.
Well, I did this once. I'll do it again.
What's the other?
I wrote very small.
There's another one.
We have to close it at chapter.
I think we're supposed to be halfway. I haven't just got the book in. What? No, I was there. Wait, so. Have you guys done?
They didn't they killed Mockingbird.
Did you get, you guys do Super Mario? Yeah, we did that. You did the.
We did
Everybody
the
A. What was that called? Crucible?
Crucible?
Yeah.
I'm using every and shovel.
The book.
Yeah.
I mean, like.
Alright, watch this. We're gonna take quiz on it today. I'm gonna have no idea what's happening. I've tried to listen to it.
We're supposed to read.
Is it what is it about? I know we went into the interview or whatever. And you had to interview. Yeah. Was that yeah, was that all it was over?
So, I we probably around a year.
He did.
Yeah.
You didn't see me, like That's right.
Fire. We're supposed to finish the fall. It's the elevator. There's like 5.
Yeah, I saw, I think, I know. I don't know. I'm not clueless, but I probably am.
Yeah. Oh my no. Oh, there's one of those papers that are like 80.
Yeah, it's like 100.
80 pages. There's one like this one. Yeah. There's one that's like one. And this one, page 52 to 180.
It's probably the most important.
The next one is I haven't read any of it either.
Get the graphic.
It's due tomorrow.
It's like 2 hours to read.
No, just the
What I did.
only 2 hours.
Yeah, I read through it in 2 hours, and it gets close to the details.
It's
Especially
just
if you have a reading. There's-
I can barely.
Well, that's like. the
This is
whole-
fun. Just do what we did in that class.
Creative. Just look at all.
Yeah.
Yeah, I know, okay. Actually, we
1924,
were.
Raise your world.
How many books you said? He said, yeah, he said that's the. Oh,
That's why I did my best.
oh my God. No.
Yeah. But
Only.
you do it over a whole semester, you get like at least.
Oh my. I
So-
have done zero essays, 0 books. That's, I'm in grade.
And for some reason,
And I just go.
Oh my God.
Let's just read from
All right. Woo! Terribly hot. Okay, guys, let's keep going here. So everything that we just did here, those would be more like linear types of equations. They're not linear, but they're kind of looking like linear equations. I treat them as. We're going to do one more of this type, okay? So here we go. How about, oh, this is a good one. All right, here it is. So before I ever change this to another function, I have to isolate it first. So the first step is always going to be to isolate this. So if I want to isolate secant x, my first step would be to subtract 2 from both sides. Great. And then, of course, I'm going to divide by radical 3. So now I've got that the secant of x equals -2 over radical 3. Now I do my, I don't like secants. I would rather write this as cosine, right? So I'm going to write this as the cosine of x equals, all I do is flip them both, guys. That's it. Negative radical 3 over 2. And now I say, okay, cosine is negative in quadrants 2 and 3. So I know my angles now that have an x coordinate of negative radical 3 over 2 are at 5 pi over 6 and 7 pi over 6. Right. Again, we kind of treat it like the linear type, and then at the very end, once I get secant by itself, I flip it. Okay? Anything you want to ask before I go to like another step up from this? Okay? All right. So before I do the next trig equation, I'm going to do a regular algebraic equation. This is a tough one. Don't freak out. So now instead of being linear, this would kind of be called a what? If this is x squared, it is quadratic in form, right? Okay, now, how do I solve this? Well, this one I have a choice. I could factor the left-hand side, that's one option, but on this one, I could just add 4 to both sides and say x squared equals 4, and then I would take the square root of both sides. And then I have to remember when I take the square root, there's both a positive and a negative root, right? Okay. That's quadratic. And that's a quadratic where you don't have to factor, you can just use the square root property. All right? Now we're going to go ahead and think of that exactly the same type of problem, but it's a trig equation. So here we go. All right. So I get this. Okay. Remember, before I can take the square root of both sides, I must isolate. I have to isolate this. Isolate. Okay. What's the first step in isolating sine squared x? Add 3 to both sides. Yeah, exactly. So I get 4 times the sine squared of x equals 3. Divide by 4 on both sides. Sine squared x equals 3/4. Take the square root. Okay, now in doing that, I get that the sine of x equals positive and negative radical 3 over what? 2. Okay, now I want everyone to just think. I want everyone to think about this. Yeah, we'll do this. Okay? Okay. I've drawn 4 angles up there this time. Why? Why do I have 4 angles up there, not 2 like I did in the previous problems? Right. Because it's plus and minus. So now let's think about this. In Algebra 1, a linear equation had 1 solution. In Algebra 2, a quadratic had 2 solutions, right? Twice as many. In trig equations, a linear style has usually 2. A quadratic will have twice that, which is 4. So now when I'm doing this, I'm not going to have 2 solutions. I'm going to end up with 4 on this one now. So where does this happen at? It happens at x equals what? pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. I do not need to write them in any order like, oh, the positive ones happen here and the negative ones happen here. I don't have to do that. I only have to write down where is it that these two things could possibly happen. 4 solutions this time. If you have an x squared, you may have more than 2 solutions. Very good chance you're going to have 4 solutions. Because you have to do positive and negative roots, which means now you don't just have positive quadrants, now you have, or coordinates, now you have positive and negative coordinates. So you double the amount that you have. Okay? Is everybody okay with that problem, what I just did? Questions on that problem? Yeah, Krista. This 5 pi over 3. Okay, let's try another one. Let's do, oh, this is a nice one. All right. It's a cosecant. I don't like that. I'm going to be changing it later, but not until I get this thing isolated. So my first objective is to get this by itself. So what am I going to do to get that by itself? This is no different than if I gave you this problem right here, guys. Yeah, you would subtract 4 from both sides. Now what? Divide by negative 3. Now, I'm not going to flip it yet. I can flip it now if I want, or I can take the square root of both sides. That's up to me. Okay? So let's do it the first time. We'll take the square root of both sides, and we'll see. You can choose which way you like to do this, okay? I'm going to write this down twice, guys. All right, if I take the square root of both sides here, I would get that the cosecant of x is equal to positive and negative what? Two over radical 3. Now, at this point in time, I would have to do what? Flip these. And if I flip these, I would get what? Cosecant x, if I flip it, is sine. So it's the sine of x equals positive, negative, radical 3 over 2. Okay, I'm going to come back to that in a second. We'll finish it. If I did this one over here, and instead I flipped it right away, what happens? I would get that the sine squared of x equals 3 over 4. And then I would take the square root of both sides, and I'd say that the sine of x equals positive, negative, radical 3 over 2. Notice both ways you can do the exact same location there. So when I isolate it, at that point in time, I can flip it, or I can take the square root and flip it afterwards. Those are interchangeable. Now I have to finish this. Doesn't matter which one I use. Where is the sign, positive or negative, radical 3 over 2? Yep. Any questions on that one? No. We're good. Okay. Here we go. We'll try another one. So that was solving a quadratic type by square root. Okay. What if I gave you instead this quadratic? Tell me how to solve that algebraically. How do I solve that algebraically? Greatest common factor, beautiful. Greatest common factor, you factor it. X times x plus 3 equals 0. And then once you had it factored, what did you do? I wouldn't write down the answers yet. I always told you to do what? Set each factor equal to 0. Why? Because if I multiply two things and get a product of 0, that means both or one of my factors is equal to 0. So I know that x equals 0 or x plus 3 equals 0, right? That's true. So then my solutions are x equals 0 and x equals -3. You guys remember doing that? Hopefully. Great. That same idea can apply to trig equations. All right? That exact same idea. So this is the greatest common factor. So we factored by doing a greatest common factor idea. Here we go. All right, here it is. So it's quadratic in form because it has a square. High powers of square. It's quadratic in form. These are the type you want to get. If you have this, you want to get it set equal to 0. So my first step here is to get all the sine x's on one side. So I'm going to start off by subtracting 2 sine x from both sides. So on the left, I get sine squared x minus 2 sine x equals 0. Now at this point in time, it's a GCF. What is the greatest common factor? Sine of x. So I get sine of x times 1 minus, I'm sorry, not 1, sine x minus 2, right? Equals 0. Okay, now I set each factor equal to 0. Okay, here we go. So the sine of x equals 0 and sine of x minus 2 equals 0. When does the sine of x equal 0? At 0 and pi, right? That's where the y value is 0, guys. Then this one would be that the sine of x equals 2. Is the sine or cosine ever bigger than 1? No. So this here has no solution to it, does it? So the solution to this equation is what? 0 and pi. Right. Boom. Okay. That was doing by another one by greatest common factor. Getting everything on one side, doing the greatest common factor. We're going to try another one like that. You got a ton of examples coming your way today. Yeah, I think I have another one. Oh, yeah, baby. This is nice. Here we go. This is the first one we've done that looks like this. Okay, now, this is the first one we've done where it has 2 different trig functions in it. Don't freak out. It's not quadratic, is it? At least it doesn't look quadratic, but it is kind of quadratic because cotangent could be what? Cosine over, which would give me a cosine squared then, wouldn't it? So it is kind of quadratic. It just doesn't, the way it's written, it's not. Okay, so what am I going to do? What do you think might be a good idea here? Get everything on one side. Now, here's something you're not going to do. never, ever divide both sides by a trig function. In other words, if you say, I'm going to divide both sides by cotangent x, no, not allowed. Because when you divide by a trig function and eliminate it, you very well are eliminating possible solutions. So you may not do that. You may not divide by that. Okay? All right. So my first step is I'm going to get everything on one side. So I'm going to subtract a cotangent x from both sides. On the left, I'm going to get cosine x, cotangent x, minus cotangent x equals 0. Now I can GCF. What is the greatest common factor on the left? Cotangent x. So I get cotangent of x times cosine x minus 1 equals 0. Now, split it up. Two new equations come from this. The cotangent of x equals 0, and cosine x minus 1 equals 0. Okay, let's start with this one. Cotangent is what over what? Cosine. Cosine over sine. So what this is really asking me is where is the cosine equal to what? 0. That's what this is asking me, guys. Where is the cosine equal to 0 at? What's that? Pi? Half pi and 3 pi over 2. This is at pi over 2 and 3 pi over 2. Because at those two locations, here and here, this is at what? 0, 1, and this is at 0, -1. And I know that this is cosine over sine, which is the same as x over y. So 0 over 1 is 0. 0 over -1 is 0. Right? Then over here, I keep going. Oh, that means that the cosine of x equals 1. Where does that happen at? So the cosine of x is 1 at 0. I don't have to write 2 pi, it's a repeat. How many solutions? 3 this time. That's okay. That's completely fine.
Why doesn't, like, you subtract the cotangent x from both sides? Why doesn't it just cancel out? Like, why do you-
Because that would be like, because this right here, you can't cancel this out. This would be like x, y minus y. Yeah, because this variable here is stopping it from doing that. Okay, yeah.
So like, the cosine and the cotangent are like kind of like they're stuck together.
They're multiplied.
Because I had thought that it would distribute.
No, because you're subtracting. You're not. If you were multiplying both sides by cotangent x, then you'd kick it through. Okay, so this is kind of like if I gave you x, y equals y. This would be x, y minus y equals 0. It'd be this. That idea. And those are not like terms, are they? Like terms means you have to have the exact same variables, exact same combination of variables. This is not the same. So these are not like terms. That's why you can't actually combine them. You can only take cosine x, cotangent x, and add or subtract other cosine x, cotangent x's to it. And actually simplify it down. So there's one that you have to factor on with the GCF, but it doesn't look quadratic. But what did we notice? It has the same function on both sides, the same trig functions on both sides. And then moving it, I'm able to make it factorable. Okay? Let's see. Let's try one more. Okay, here we go. Before I do this last type, what if I gave you, we're going back to September. I know that's a bad idea. I don't want to go back to September and start this year over unless we were just here every day. So let's say I gave you this. Okay. How would I go about solving this?
Oh, no, you
Now, and you could say quadratic formula, but that's not what I'm looking for here. I think Brady said it. It's factoring. Okay? X squared has to come from x times product of negative 12 and a sum of negative 1. 3 and 4, and 1 is those is positive and 1 is negative. Yep. So being able to factor like this still, basic ones. Okay? And then I'd say what? Oh, x plus 3 equals 0, and x minus 4 equals 0. So x equals negative 3, and x equals 4. That's a full-fledged quadratic. Okay, 3-term quadratic. Your trig functions can look like that as well if you're solving them. So let's look at one that resembles that style. Here we go. All right, this is it. So I look at this. There is no GCF. So I need, when I'm looking at this, guys, okay, I'm visualizing this is kind of like I'm asking you to factor 2x squared minus 3x plus 1. That's what you have to think of it like this. How would I factor this? I factor that the exact same way. Okay. So what would we do? Well, if it's 2 sine squared x, I only have one choice for that. It has to be a 2 sine x and a sine x. Just like down here, this would have to be a 2x and an x. Same idea. But getting a product of 1, there's no option, is there? It's got to be 1 and 1. 1, 1, 1, 1. Okay, now, I need to get a negative 3 in the middle. And if this is positive, these signs have to be if they're the same and the middle is negative, then they both have to be negative. So if I know how to factor this, you factor this the same style. It's the same way. Don't let the sine x get in the way of factoring. Now I can go ahead and keep going. I do what? Set each factor equal to 0. So I get 2 sine x minus 1 equals 0, and sine x minus 1 equals 0. This one gives me that the sine of x equals what? 1/2. This one gives me that the sine of x equals 1. All right, here we go. This one. Where does the sine of x equal 1/2? When x equals pi over 6 and 5 pi over 6. This one, where is the sine of x equal 1? Where x is equal to pi over 2. Notice that a lot of the algebra I'm using is the algebra you did in Algebra 2. The algebraic skills for solving this, getting it down to the isolated trig functions is what you did in Algebra 2, or even Algebra 1, some of it was. And then it's only after you get it isolated down to this point that you have to use your trig. This is where the trig is being used. Not here, not here. This is Algebra 2. Then, once we get here and here, then we start using our knowledge of trig to finish it up. All right? Now, let me show you a more complex quadratic. I want you to be paying attention because Now you're going to understand why we were doing what we did the previous weeks with this next problem. All right, here we go. All right, so here we go. This one also has two different trig functions in it. Okay. Now, I do not like that I have a sine squared, a second degree sine, and a first degree cosine together. I do not like that. This is where knowing my trig identities comes into play. One of those can be turned into the other one quite easily. Because I should know that this is equivalent to 1 minus cosine squared x. So those trig identities now can be used in solving them as well. Now my next step would be to what? Distribute the two through. So I would get 2 minus 2 cosine squared of x equals 2 plus cosine x. Now I have to get everything on one side. What side you choose to put it on is up to you. Guess which one I'm going to move. I'm going to move the cosine squared x because I don't want this to be a negative in front. I'd rather it was a positive. So what am I going to do? I'm going to subtract 2 and add a 2 cosine squared x to both sides. Right? Subtract 2 and add a 2 cosine squared x to both sides. Okay, what do I get on the left? Somebody said it. 0 equals 2 minus 2. Gone. Can you actually combine? This is squared, by the way. Can you actually combine these? So you get 2 cosine squared x plus cosine x. Oh, guess what I'm going to do now? GCF, greatest common factor. 0 equals 2 equals cosine x times 2 cosine x plus 1. Whoop. Keep going. Set each one equal to 0. Cosine x equals 0 and 2 cosine x plus 1 equals 0. Solutions. When does the cosine of x equal 0? Pi over 2 and 3 pi over 2. Over here, when does the cosine of x equal negative 1/2? Subtract 1, divide by 2. Nope. Cosine is negative in quadrants 2 and 3. 2 pi over 3 and 4 pi over 3. Do you have to know the unit circle? You do. If you want to be able to get this done. You got to know them. Okay? All right. This is what we're doing, guys, and this is not the hardest type. Yes? You mean here, move the 2 over here, you said? And then do what?
And then you would just have your 2.
You would have 2 sine squared x minus 2. You can factor out a 2 then, if you wanted. Is that what you meant? But this would still be in terms of sine squared. Though. You have to, at some point, you have to convert it into cosine squared.
So if you subtract your 2, you get 2 sine squared x minus 2, and that's the same as 2 cosine squared.
If I go ahead and start off here and make this 2 sine squared x minus 2 on the left, I'd have to factor out a 2 like this and make this sine squared x minus 1, which is negative cosine squared x. Because if that 1 comes over here to be negative, then that cosine squared's got to go to the other side and become a negative. that make sense? Your thinking's good, just be careful. Okay? Yeah, you could do it this way and go, oh, that's 2 times negative cosine squared x, which is basically what's going to happen down here somewhere. I know it is. Yep. Okay. All right. This is where we're at, guys. This is it. We really need to step it up here. We got to finish strong. Okay. So I'm going to write some problems down on the board. Since you guys, the book thing is just a fiasco, so I'm not going to worry about that. So you have all of these examples. This will all be posted online for you to look at. Okay? So I'll post the notes. You can go through, you can look at what we've done, and then you're going to try the following problems tonight. I'm just going to write them down up here. And this is your assignment. All of these problems you're going to solve so that x is between 0 and 2 pi. All of these. Okay? 0 to 2 pi. All right, here we go. Number 1. And I'm giving you kind of like the ones I did in here. Same kind of a concept. Starting from easier to harder ones. Do not freak out when you see a tangent cubed x. Don't freak out on that. I have faith in you. Actually, stop. Back it. I don't want that one. Wrong one I just chose. One more. All right. 10 problems tonight. And if you still don't know your unit circle very well, you've got to be doing that as well. Setting those things up. If you didn't do delta math, do not worry about it now. Concentrate on these. Okay. So Owen is missing. Noah's missing. Caitlin, when's best for you? Let me ask you this. You know how we have like 2 to 3, 2:15 to 3:15. We're here still. Are you able to do it at that point in time? Any of these days coming up quickly? Let's do that then. Okay. Yeah. Because I knew time-wise, I wanted to get through all this first. I had to, unfortunately, use a little time here for this, so. Okay, that's done. What's this? Delete this. Okay. Post all that. Think that'll check that. Oh. See you guys tomorrow.